Lesson 13.5 is finding angles, but with justification. And justification is you're justifying each step that you take. And this is our first preview into what proofs look like. So proofs will be a table. You always have your step and then your reason behind that step. And so since we're just dealing with angles in this, we're just going to have the steps be just dealing with angles. So like on number 1, I already see that lines will be parallel and perpendicular. I'm not going to write those things. I'm only going to write the things that tell me about these angles specifically. Okay, and so on Delta Math also, they'll have drop down buttons that you push and it'll give you all of these, but I put it up here so we can see all of them at once. So that's kind of nice. So number 1, it tells us that AD is parallel to EG, and so AD would be this line, EG would be this line, so I'm going to make my arrows there, and line BH is perpendicular to FC, so that's why we have a 90 right there. Then it also tells me that the measure of angle GFH right here is 58 degrees. So that's actually the first thing I'm going to write down, and I'm going to put step 1. The measure of angle GFH is 58 degrees. You got to write kind of slow. And that, small, sorry. And then the reason is it's given to us. We didn't have to do any work to get that. And I always look ahead at what am I trying to find? I'm trying to find the measure of angle HBC. So the first thing I notice is that FC is a transversal to my parallels. So if I were to have this angle 58, I also know here at HCB would be 58 degrees. So I'm going to put that as step number 2. Measure of angle HCB, and it doesn't matter how you name it. You could do BCH as well. You just couldn't call it C because there's also an obtuse angle here at C on the other side. And we've got to figure out, how do we know that? Well, if this is our transversal of our parallels, these would be alternate interior angles. And so I see that right there. And you can abbreviate. Alternate interior angles. Okay, and so then I could go ahead and figure out this one. I should probably go on and put, though, that we know here at angle BHC is 90 degrees. So that seems silly because, yeah, they have the symbol there, but a proof requires you to tell every step. There should not be nothing that is assumed. And so how do I know that this is 90? Well, because they told me that they were perpendicular. So I would use this one right here. Perpendicular lines form right angles. That's how I know that's 90. So perpendicular lines form right angles. Then I can say what the measure of angle HBC is. Because all I have to do is take 180 minus 58 minus 90, and I get that to be 32 degrees. And how did I know that? Well, I knew that there's 180 degrees in a triangle, so I would say sum of angles in a triangle. So anytime that you're using the 180 degrees in a triangle, so you're subtracting the angles you know from it, that would be the reasoning. All right, number 2, kind of looks like a bow tie. Tells me that line AE is congruent to BE. So AE and BE are the same length. DE is the same length as DC. And the measure of angle D is 32 degrees. They show us in the picture. Find the measure of angle A. Okay, so my step 1 that I would include is that the measure of angle D is 32 degrees, and that was given to us. And then I look at this triangle. Always start with what you're given and work from there. This must be an isosceles triangle, so I could figure out these two base angles. I know that they're congruent by taking 180 minus 32 and then splitting that in half. So each angle would be 74 degrees. And I know I'm going to have to work over here in this triangle because it doesn't tell me anything about parallel lines. So I'm going to state that angle CED is 74 degrees. We've got to find some kind of reasoning behind that. I know I did something with isosceles, an isosceles triangle, and I did something with the base angles. So I would pick this one right here. It's a base angle of an isosceles triangle. Okay, I wouldn't want to just do the sum of angles in a triangle because that's not super specific. I didn't know 2 of the angles, I only knew 1. All right, from there, I can see that this angle here would also be 74 degrees because these are vertical angles. So I'll put that the measure of angle AEB is also 74. And I see that being my first reasoning in my list because they're vertical angles. And then I also see that this is an isosceles triangle where these angles should be congruent. And so I would do 180 minus 74 and then divide that by 2. It should be 53. So I found that the measure of, I can just call it angle A, is 53. And again, that would be dealing with the isosceles triangle, so that would be the same reasoning as step number 2. All right, and then last one. In the diagram below, segment AB is congruent to BD, is congruent to BC. Interesting. And the measure of angle C is 65. Find the measure of angle ADC. ADC. So that would be this whole thing here. All right, the only thing they give us is the measure of angle C being 65. That's our given. The next thing I'm thinking is in this triangle, this is isosceles, so these would be the same here. So that must be 65 degrees. So I'll put that next. I can't just call it angle D, I'll call it CDB. And that's the base angle of an isosceles triangle. Then I could figure out here, because I know there's 180 degrees total, so 180 minus 65 minus 65 tells me that this angle's 50. CBD. And that was that sum of angles in a triangle. Okay, then I have a linear pair here, right? These should add to make 180. So 180 minus 50 is 130. So I'll say measure of angle DBA, 130. And that's something about a linear pair. Right here it says or triple. Sometimes you have a line and you'll have maybe 3 angles here, here, and here, making a linear triple, but we're going to say linear pair. Okay, and then this triangle was also isosceles, so it'll have a base angle that's congruent here to here. I don't think I have enough steps, so we'll do 180 minus 130. I don't know why I just did that. That's 50. Divided by 2 would mean they're 25 degrees. So that would be the measure of angle BDA. And that would be base angle of isosceles. And then really I need to add step number 6. I'm going to have to add 65 plus 25. That would be 60, 80, 90. That's actually a right angle. So measure of angle ADC is 90 degrees. And then I'm not dealing in a triangle right here. I'm just adding these two. So remember that's called, where you at? Angle addition postulate. When I add angles next to each other, that's what that is. So it's an angle addition postulate. Postulate's just like a rule or a theorem. And that's it. That's our first proofs that we've ever done.